All right, so we are going to be continuing from where we stopped yesterday. I'm going to share my screen now. All right, so we would continue from where we stopped yesterday. So yesterday, let me just briefly go through what we talked about yesterday to refresh your memory. Yesterday, we talked about for loops. We continued with our Python programming advanced concept. So we talked about for loops, for and while loops. Talked about functions, right? So we were able to introduce to us functions in Python. I remember what I said about functions, what functions are, how to define a function, right? So I gave examples of the function in the class yesterday. Although we're not able to talk extensively on function, but we had an introduction on what functions are, right? So I sent a material, a YouTube video link. I dropped it on the Google Classroom for you to um, to have a better understanding of what functions are. So I am urging all also to go through the material I dropped and just go through them. Like once you are done going through all these materials, definitely you will be satisfied with the concept and you will have a better understanding. Right. So for the sake of time, I'm going to be going straight to what we have for today. Right. So today we are supposed to start with NumPy, right? We are supposed to start with NumPy, right? But there's a very important concept in Python that you need to understand first before moving on to libraries for data analysis and data science, right? So there's what we call objects in Python. So today we are going to be starting with what objects are in Python, right? So objects, let me just give a very relatable example. So everything currently that we can touch, we can interact with is an object. We all know that. Your phone is an object. Your laptop is an object. You yourself, you're an object, right? So everything literally is an object, right? And all these objects we have, they belong to a particular class. So a phone is not the same object as your laptop, although they are devices, but they have differences, right? There are differences. There are things that differentiate these two objects. There are attributes that differentiate this object. A fan is an object. A fan is not the same object as a car. A car is also an object, but it's not the same object as a car. It's in a different class of objects, right? So I just need you to understand this concept before we move to talk about objects in Python itself. So just have this understanding of objects as basically anything that coming to our real world, anything that you can touch, you can feel, you can interact with, they are all objects, and all of them belong to a particular class. So why am I saying this? You would get to understand why I'm using this particular example. So now let me just zoom in so you see the material better. Give me a second, please. Okay, sorry for that. I need to do something. So now objects, as I said, so you should be able to see my screen better now. So as you can see, everything in Python is an object. Even values of primitive types, integer, string, float, those things that we talked about, they are objects. Lists are objects. Tuples are objects. Dictionaries are objects. Everything in Python. The same thing, the same way everything in our real life, in the real world, is an object. It carries the same meaning into Python. So everything in Python too is also an object. So you have to treat them that way, right? So why am I saying this? I'm saying this because this object behave differently. different objects in Python behave differently. They have different attributes. So there are two concepts now I want you to understand very well, right? There's a reason why I wanted us to talk about object, because when we start talking about NumPy, when we start talking about pandas and other libraries for data science, we are literally going to be using the concept we are going to be explaining today. Everything I'm going to be talking today regarding object is what we are going to be using when working with NumPy, when working with pandas, when working with other data science libraries. So I need you to understand this concept very well. So all objects have what we call attributes and what methods. So these attributes and methods, they can be accessed using the dot syntax. Don't worry, I'll demonstrate all this in code, but just try to understand, follow me here, right? So right now, let me explain what attributes are before moving on to those examples. So now attributes, they are like characteristics or properties of an object. So the same way a car is an object, right? I give you an example of objects in our real life. So a car is an example of an object. Yeah, it's an example of an object. And a car has attributes. Those attributes are the characteristics and the properties of the car, right? So you can say, for example, now a car might have things like color. If you buy a car, your car should have color. It is not invincible, right? So it should have a color. It should have a make, right? It should have a model. It should have a year. So these are the things that you can use to know what this object is. They are the attributes of that object. So the same thing applies to Python objects too. So every object in Python have what we call attributes. So all these things I've been talking about in the previous classes, like our data types, the integer, the float, the list, the tuple, the dictionary, the set, all of them are objects. And all those objects have different attributes, right? So now the attributes that one object might have will not be the same attributes that another object would have, right? Now a car has an attribute of 4 wheels. It has 4 wheels, like that is a standard car, right? It has 4 wheels. Like I'm just trying to generalize. Now I know we have subdivisions of vehicles, right? So, but normally a car, when you think of a car, you know that a car has 4 wheels. So now that is an attribute of a car. So that attribute now is specific to a car. You cannot carry a phone now and say a phone will have 4 wheels, right? A phone is a different object from a car, so it would now have different attributes. So a phone attribute might have a screen, a big screen, depending on the screen size. It has some phones have button, right? A phone have battery. So these are the attributes of that particular object. So let me not dwell so much on that. So now I just wanted you to understand what attributes are. So they are characteristics or properties of an object. So now for a list, let me just use a Python object for example. Like a list is a Python is an object in Python. So a list has attributes, right? So we're going to talk about those attributes after when we are giving examples. A list has an attribute that is different from the attributes that a tuple will have, because a list and tuple, they are different objects in Python. Both of them are objects, right? But they belong to different classes of objects. So they will behave differently. I need you to understand that. Just keep that by the side. All right. So now we've talked about attributes. Now let's talk about methods. Methods. So methods now, this notation can be confusing, but methods are like functions. Methods are functions basically, right? So methods are used when you are associating it with an object. So method is basically the behavior or action. They represent actions or behaviors that the object can perform, right? So a car now, let me just use the same example. A car would perform a different action from your laptop, right? So a car can start, it can stop, it can accelerate, it can brake, it can carry people, it can do a lot of things. It has functionalities, right? So this is what we call methods in Python. So the behaviors, right? This behavior now is different from characteristics. So characteristics are just like something you will see and you can describe it. That's what characteristics is. But method is like a function. Like if you tell this thing to do something, it will do it. So these two things, they are different. So I need you to understand the differences between attributes and methods. But there's one thing I want you to know. Generally, most people that write Python code, most people that use Python, they call both attributes and methods attributes. They refer to everything as attributes. So sometimes you might see some people calling methods attributes, right? It's just what the general Python community refer to refer methods to, right? So sometimes, but the specific name for the functionalities of an object is a method. But sometimes, I'm just telling you this so you don't get confused. Sometimes it might see people calling it methods, be attributes instead of method. So they'll call both the attributes and call both the method to attributes. So just note that. So now this is basically the two things you need to know regarding objects in Python. So so if you are taking notes, just know that everything in Python is what? An object. And objects what? Objects have attributes and methods. And attributes are what? Characteristics or properties of that particular object. Why methods are what? Methods are like the behaviors or the functionality of those of that particular object or those objects. So that should explain that. That should do justice to what methods, objects are, methods and attributes, right? So now let's go into using example to illustrate it better. So now we have, for example, let me create a new file. Let me get feedback in the group if you all are understanding so far and you're following. Let me get feedbacks in the group chat so I'll know exactly where you are. All right, great. Is my voice echoing? Please let me know in the group chat. Is my voice echoing? Is my voice okay? Please, can I get more feedback? Is my voice okay? All right, great. Perfect. So now I'm going to demonstrate what objects are and how you can access methods, the methods and the attributes of an object. So for instance, we've been using list for a while now. We've been working on list and using list as examples. So let's just create a random list. Let's say my list. Don't worry, I'm actually not good at naming variables. I don't have plenty variable names in my head, so you just have to manage that. So let's just create a list with just several elements, just some few data types. So we now have this particular list. We have my list, the variable, and we have the values that is assigned to this list. So this list that we've created, this particular item is an object. It is what? An object. So, and I said an object what has methods and what? Attributes. Methods are the functionality of an object and attributes are what? The characteristics of the object. If you remember, there's an assignment I gave you. There's a particular assignment I asked you to check a particular fruit list and check if guava, avocado, pawpaw, and apple are in that list. If they are in the list, you print what? yes, this fruit is in this list, but if they are not in the list, you would what append, attach in that particular fruit to the list. So that action that we carried out, which is appending a new item to the list, is an action that we are taking. So that is actually a functionality of a list. That is a method. That's an example of a method. So you can call it function, right? So just there are so many things you can call. You can call it function. You can call it methods. You can call it attributes, right? Just have the understanding, just understand the idea of what this particular concept is. So let me use the example, right? So I'll come here. Let's say I want to add something to this particular list. I want to add my name to this list. I'll come and say my list dot. Remember when I was talking about sorry, when I was talking about objects, we said that objects have attributes and method that can be accessed using the dot syntax, right? Using the dot syntax. So this is what the dot syntax is. After you've typed that your object out, you can now put dots. This is the dot syntax that we mean there. This dot will now be followed by the method particular or specific to that object. So this object has a method called append. So this append is a function that is specific to this object. This object here is a list. So we can append a new item to the list by just using the append function. And I told you that functions always have brackets, open and close brackets, right? So don't get confused now. Remember we talked about function yesterday and we said functions that always have bracket. And when I was talking about method, I said methods are also functions, but they are functions that are particular or that are specific to a particular list, right? So to access that particular function, you have to write that object followed by a dot, and then the method or the function. So you say append, and then you can just whatever it is you want to. Let's say you want to add career X, right? So what this particular, let me use a comment here, appending a new item to the list. So what is going to happen here is that this career X now is going to be added to this list. So this list is going to be extended and would have another item in this list. So if I run this, I'm going to have the code. So we can't see anything now because what? Who can tell me why we can't see anything in the group chat? Why can't we see anything? So it has appended it, right? But why can't we see anything? It's just a very simple. I just need this class to be interactive. Exactly, because we're not printing it out. So to see the action that we've done, we can just say print, then my list. So if we print my list, what do we have here? Everybody got it. You guys got it. Perfect. Like I really love that. So once we print the list out, we are going to see that career X has been added to this list we created. So this action we took now is something that is specific to this list object. So this is a behavior of a list, right? So it's not all objects that can append, that you can do this particular operation or this particular action on, right? So now you might be asking, how do we know the methods or the things that a particular object can do? So there's a particular function that I would need you to pay very good attention to. It is called dir. Let me zoom in, right? So it is called dir. This is a function, a built-in function. Remember yesterday we talked about functions, we talked about built-in function, we talked about what are the two types of functions again? Let me see responses in the group. What are the two types of functions we talked about yesterday? Two types of function. Hope you guys remember. I'm waiting for your feedbacks in the group chat. What are the two types of functions? Exactly. We have built-in functions and we also have user-defined functions. Exactly. Inbuilt function, built-in functions, and user-defined functions. So all the functions we've been using all this while, they are built-in functions, right? So the ones that are user-defined are the one we use def and that we create by ourselves. That is user-defined function. So this dir now is a built-in function. It comes with Python, so you need to know it. So there are actually long list of built-in functions you should know. They are very important. They are very, very important. After this class, I'm going to drop a cheat sheet that would list out all the built-in functions that we have in Python that are very important. So this dir functions function particularly, what it does is that it lists out all the attributes and all the methods of a particular object. What did I say? Dir function now that we are about to use now, it lists out all the methods and all the attributes of an object. So sometimes you might forget. That is very, very common. Even if you've been coding Python, you've been writing Python for a long time, sometimes you might forget the particular method you want to use. So you can just use this dir function to check for the methods and the attributes of that object. So if you come here and say dir and then you say, oh, we want to check for the attribute and the method of my list, we can come here and type my list, right? So we'll put print. So we're going to see exactly what is this. So if I run this now, you see what the output is now. I'm getting a lot of stuff, a lot of so now, first of all, from all these things that have underscore, don't disturb yourself about them. Like, it no concern you. It's not your business as it pertains to what we are doing, right? So don't disturb yourself about from here. Anytime you use this dir function, you will always get some methods that have this underscore. Don't disturb yourself about that. The one you are concerned about are the ones that don't have underscore. So from here now, append till sort. These are the ones that you would pay attention to. So now these are the methods particular to a list object, right? Let me just show you something else so you understand clearly what I'm saying. If we come here now and we create a variable number, an int number, and we just say 5. So we use this dir function to check for the attributes and the methods of this object 5. We come here and say print dir int number. So you can actually just put the number directly here. Like, it will still do the same thing. The reason why we are using integer is just for you to be able to call this particular value anywhere in your code. So you can come here and say int num, right? If we print this is what we're going to see. I'm going to see plenty stuff like that. It can be confusing. So as I said, everything that has underscore is not your business. Don't disturb yourself about them. So these are the ones that you pay attention to. So now, as you can see now, we have different methods and attributes for an integer object, and we have different methods for a list object. Have you seen what I'm trying to explain that time? I was trying to explain that a car is an object. Your standing fan is an object. But these are two different kind of objects under different class of objects, right? A car is under the class of vehicles. Your fan is under the class of, let's say, fan, right? So they behave differently. So as you can see here, there are different behaviors of a list and there are different behaviors of an integer, right? So we might not be able to explain or go through everything that we have here. So this is just going to be left to you to explore, right? Now on your own, you can just come any object you find, you can you can just explore all the methods that we have there, right? Because of time, we might not be able to go through all of them, right? So, and sometimes you will not be using all these attributes or methods, right? So there are just few of them that you'll be using frequently. So as you can see in this list method, we have the append, right? So we have the append function that we used initially. You can see it is here. So we have clear, we have copy, we have count, we have extend. So let me just use some of these as examples. So all right, like let me go on first. We'll come to that. So basically, that's what an object is, and that is what methods and attributes are. Right. So for list, we have different. For integers, we have different. Right. So we're going to just explore some of the objects and some of the methods and some of the attributes of this object. So for integer now, you can see attributes and methods for the various data types in Python. So integer, it has an attribute, bit length. So what does this bit length do? It returns the number of bits necessary to represent the integer in binary, excluding instead. So this is not something you will need, right? So it's, as you can see, not every of these attributes would be useful for you. It might be useful for other persons that are using Python, maybe software developers, because remember I said Python is not just for data science, it's a general purpose programming language. So this is the foundation. Everybody has to understand all these things. Then you now move on to learn the libraries that are particular to data science. So you might not be using all these things, right? But it's not like you don't need the knowledge. It's a very good thing to know. So for floats, these are the attributes, some of the attributes for float of a float, right? This real returns the real part of the floating number. Return. So basically, you can practice all these things by yourself. So you can just come here and say, let's say for this integer now, you can come, right? So we use this dir function to get all the attributes. So if I come here, you see, right, the bit length attributes here. So basically, if you want to know what to do and how it works, you can just bring your int object and use the dot. So this dot is what you are going to be using to access all these things. If you not put any dots here, you won't it will not work. It will give you an error. So you have to put the object then followed by a dot, and then any of these attribute or methods here, you can now type it out. So let's say bit length. So I don't know if this one is so now this is a function, right? A method of an integer. And what it does is that it returns the number of bits necessary to represent it. So this doesn't concern you basically. I'm just trying to show you exactly how to access this methods. So let's move on. So float, the same thing. You can be practicing on your own just to explore. Just follow your curiosity. Now, this is you don't even need this, right? So string, now this is something you might be using, right? This is something you might be using. So string has several methods. String has several methods. So as you can see, that's capitalized. It what returns a copy of the string with the first character capitalized and the rest lowercase. So we have upper. This basically converts your string to uppercase. We have lower, we have strip, so basically we have a lot of them, right? So as you are moving on, you see the usefulness of each of these methods. So let me just illustrate with these first three methods. So we can come here and create a string variable, string var. Python is easy. Or let me just use small letter, right? So now I've created a string variable. I want to know the methods. Let's assume I don't know the methods and attributes of a string object. I can just come here and say dir, then we'll now pass in you can pass in your string directly, or you can just pass in Python, but you understand what I'm trying to do here. So to make everything easy, I can just say this and then print it out so I can see it well. If I print, this is what I'm going to see. So this is what I'm going to see. So as I said before, ignore everything with underscore for now. Just ignore it. You have no business with that. You will start from here. So as you can see, these are the attributes and methods of a string object, right? These things are you can only use them for a string. If you use them for a list, it will not work. It will give you an error that a list, it does not have this method, right? It does not. Let me just illustrate that to you. But I'll give you an example of this list attribute and method. But let me just use a list that we created the other time. I think we created my list. Now let's try to use capitalize now for a list. Remember, we've done list before, and a list does not have capitalize method. These are the methods in a list. So let's use a method that is not in a list. Let's just say capitalize. Right, so it's going to give me an error. And now this error now is called an attribute error. Can you see it? Like list object, have you seen it now? List object has no attribute capitalized. Can you see? We are even learning from the error. The error is even teaching you that this attribute is not part of the list object. So it will tell you that, oh, this thing you are trying to do, a list cannot do it. It's just like telling, trying to use your phone as a car. It doesn't make sense, right? So that is exactly what you're trying to do here, right? A phone cannot behave like a car. So a list cannot behave like a string. They are different objects. So I will just have to come here and use the appropriate object for a list. So I can come here and say capitalize. I created a string var dot capitalize. Then this particular method is going to convert this string. It's going to convert the first letter to a capital letter. So if I run it, you're going to see now, you can see P is in capital letter now, right? So it has converted it. So if I come and let's say I want to convert everything to capital letter, I can say upper. So if I run it, this is what I'm going to get. Can you see it now? Python is easy. Everything is in capital letter. So if I want to convert everything to lowercase, I'll just say lower Python. So basically, these are the actions that you can use. You can use in a string. So there are a lot of them. There are a lot of them here, right? So as you can see, you can just explore on your own. We don't have enough time to go through them. So that is just it for that. Our brush should be remaining. So a list has several objects: append, extend, insert, pop. So there was a time I gave an assignment, and when there was a particular assignment, I think that same fruit assignment. So some people used extend method instead of append, right? So this extend method is almost the same thing as this append, but it's just that the extend adds multiple items to a list at once. So if we come here and we say my list, let's bring my list back here. So we'll say my list dot extend. So this extend is a method or an attribute of this list. So of a list object. So I can say, let me add multiple objects like 4, 5, let's say programming, right? 6.8. So I'm adding a list of objects or of items to my list. So I can just run it. If I come here and print my list, you can see that it has automatically extended that list with the objects or the items I indicated here, right? So this is what the extend method can do. So if I use append, it will not work. Append just add one item at a time to a list. If I use let me come here and say, okay. So if I use append, what append does is that it sees this particular list as one object and adds it to this list. So as you can see now, it is adding this list inside a list, right? So I just try to understand that. I won't waste much time on that. So basically, this is how methods work. So you can just go through all these and just play around. Say dictionary has methods. So the keys returns a view of the dictionary keys. Values returns a view of the dictionary values. Items, right? So let me give more examples so you understand. I think the best way to understand the concept is by example. So let's create a dictionary. Let's say my dict. I can say name, or let's say name. This is a dictionary for footballers. Let's say um let's say Messi, right? Let's say club. For what club is Messi against? I think Miami FC. Let's say country. Which country is the club in? I think it's in USA. Gender, you can say gender. This is like a dictionary for players. So we can say male. Let's say age. I don't know. I've forgotten his particular age. So I can just put, let's say 38. So let's just stop here. See, this is a dictionary, right? Now, remember keyword value pairs, right? So I want to illustrate the methods that is peculiar to a dictionary object. So if I come here, I want to see the methods that a dictionary have access to, or the methods of a dictionary and the attributes of a dictionary. But let's, for the sake of object, let's call everything attributes. So I want to see the attributes of a dictionary. I can just come here and say my dict. Always remember this function dir, the very, very important, right? You'll be using. So I will come here and say print. So these are, first remember, forget all these ones that are in that have underscore. You come here, these are the attributes of a dictionary, right? So remember, I wanted to give an illustration of keys and values, right? So I'll just come here and say, maybe you have a very long list of dictionary that have plenty keys. So I can just come here and say, my dictionary, I want to see the keys in my dictionary. So I'll just say dot, right? And then what am I going to write next? I want feedback. What am I going to write next? Feedback, please. Feedback. I need responses. What am I going to write next after this dot? I want to get the keys of the dictionary. What am I going to write next? All right. Keys. Then followed by bracket. So if I run this code now, who can tell me the output I'm going to get? If I run this code, who can tell me the output that I'm going to be getting? What output? Based on this dictionary here. Based on this dictionary, what would be the output? Exactly, just the keys. So what are the keys here? The keys are name, club, country, gender, and age. So there are situations you want to just get the keys of a dictionary. It will give you like the keys, right? So you can even assign it to a list, right? You can assign it to a list, and now you have a keys list, right? So you can just convert it to, let's say, come here and you convert it to a list. So you have your keys now in a list, and you can use it to do what it is you want to do. Let's say your boss told you that, he gave you a dictionary, right? That has about, let's say, plenty keys. So just say you should extract those keys and put it in a list. So this is exactly how you do it. You come here, you would use this particular method or attribute of the dictionary object, and it will give you the keys, only the keys, and you can use this list function to convert the output to a list and assign it to a variable keys. So you can print that keys, just say print. You can print it and it's giving you the list. So I can also come here, I can as well come here and say the value, do the same thing for the values. I will say values. So what am I going to put here now to get just the values of the dictionary? What method am I going to put there? Exactly, values. So I'll just write values there. If I run it, this is exactly what I'm going to get. It has extracted just the values of the dictionary, right? I converted it to a list and then printed it out. So as you can see, and I have two lists. One list is what the keys of the dictionary, and another list is the value. So can you see how we are changing things, like how we are manipulating things now in Python? This is as a result of methods of objects. So this is how they behave, the actions they can take. So if you have a comprehensive knowledge of methods in Python, you can do a lot of things, right? So just go over these methods, explore them, use this dir function, explore the different methods of the different data types and or the different objects, right? Play with them, see what they do. It will help you. It will help you a lot, right? So don't just depend on the examples I'm giving here. We don't have enough time, so um, we don't have enough time, so we won't be able to go through all that. So now let's move on. So with sets, so these are I don't think we have time. So these are just some things that you can explore on your own. These are the different methods of a set, right? So that is it for objects in Python. That is it for objects in Python. Very, very, very easy and very straightforward. So I needed to explain this. So once we are talking about NumPy and every other libraries, you will not understand exactly what it is we are saying. So we'll be moving on to what we have for today. So today we are going to be introducing the libraries we use for data analysis and data science in Python, right? Introduction to pandas and NumPy. That is going to be the next topic. But for today, we'll just be exploring NumPy. We'll be exploring NumPy, right? So now there are some things you have to know. There are some things you have to know. First of all, there's what we call libraries. In Python, we have what we call libraries, right? Let me come here and say libraries. So we have two types of libraries. So we have those libraries that comes with Python itself. They are built in, just like functions, right? We have built-in libraries, and we have external libraries. Wow. All right, I got that correct. So we have built-in libraries and we have external libraries. So libraries are basically a collection of functions that perform similar tasks, right? So in Python, we have a library called math library, right? So this library is used to perform mathematical operation. So we can to import or to make use of different libraries in Python. We will use what we call the import statement. So this import statement is like saying, hey, Python, give me this particular library and give me access to everything in that library. I want to use it for something. That is what this import statement do basically, right? So I will show you exactly how to do that. So to use any library, you have to import it first. Now, for built-in libraries, you don't have to download anything. It is when you downloaded Python, it came with Python. It is inside Python. So everything is in Python. But for external libraries are those libraries that other people created. Like I can just stay from my house now and create a library in Python and add it to the list of libraries that we have in Python. Let's say I want to create a library for something, a specific purpose, maybe a data analysis library. I can create it and add it to Python list of libraries. So if someone else in another country wants to use my library, they can just they can actually have access to it by, they would have to install it first. After installing it, then they will now Why is this thing just? They will now import it. So external library does not come with your Python. So when you download Python, you will not have access to it. Now, that is where Anaconda comes in. You remember in the first class, we talked about Anaconda and how to download Anaconda. Anaconda makes all these things very easy. So when you downloaded Anaconda, you did not just download Python. You did not just download Jupyter Notebook. You downloaded all the data analysis library. Is my voice echoing? Someone said my voice is echoing. Hello, is it just the only one, or is it
No, your voice is
that?
not echoing. It's from his end.
All right, great, perfect. So we have the we have built-in libraries and we have the external libraries, right? So now I can actually create my library as I was saying, and someone from another place would download my library, install it, and then import it. So Anaconda now is a package that makes data science easy. It is a data science application, software application. So when you downloaded an Anaconda, what you did was that you downloaded Python, you downloaded Numpy, you downloaded Pandas, you downloaded all those libraries that you would use for data science, right? So actually, there are two different ways of installing Python in your system. The method we used initially was the best and simple way, which is just downloading Anaconda and you will have everything. So there's actually a different way. That one you have to download Python separately, install Jupyter Notebook separately, right? Install NumPy separately. So you'll be installing all these different libraries separately. So the Anaconda has simplified everything. So we don't even need to go through all this process that I'm talking about now. So once you download Anaconda, you can just come to your Jupyter Notebook and let's say you want to use NumPy. You will just use the import statement, this import statement I said now. Come here and say import NumPy. So once you do this, you are basically having or bringing in NumPy to this your notebook. So everything that NumPy has, you can have access to it. Now, remember, I said the dir function is very important, very important. So this NumPy that you are seeing here now is an object. If I come here and say dir NumPy, and say print, what's the problem? Okay, I've not run this code yet. All right, if I say dir NumPy, you see I'm going to get a list, plenty list. Let me zoom out so you see very well. So I'm going to get a lot of text, like plenty, right? So plenty of them. So now NumPy is a library. That's why you're having all these things. Like, so if you want to just know what NumPy can do, you can just use that dir function, and it will show you a lot of stuff. So it's going to be some confusing going through this initially, but just have a purpose when you want to use this. So it's advised that you use this dir when you want to like probably access a particular method, or you want to know the methods of a particular data type, right? So you use the dir, but using it for a package or a library like this, you would have a lot unless there's a need for you to use it. So this is basically all the things that NumPy can do, right? Same thing for pandas. If I come here and say import, right? Oh, let me just show you something now. If I do not import pandas now, and I come here and I want to see what pandas is, right? I will just say pandas. It's going to give me an error. What? Name error, name. Pandas is not defined. This basically is like you've not imported pandas, so I don't know what you're talking about. So for you to have access to pandas is also a library that we'll talk about next week. You just come here and say import pandas. So if I run this code, then it's going to take time because it's importing it. Pandas is actually a big package, so it's taking time to load. So this has it has finished running. If I come here and run it, exactly, pandas is now imported. So it has access to everything that pandas can do, right? So that is it for that. We'll talk more about these packages as we move on. So just understand this, that to use NumPy or use pandas or use any library or module, anything in Python, you have to import it first. You have to import it. So there's what we call quick one. There's what we call alias. Alias. I don't know if that's the correct pronunciation, but there's what we call alias. It's like an alternate name for something. An alternate name for something. Right. So there are some libraries that are long, like NumPy. NumPy is not so long, but we use what we call alias to represent this name NumPy. So if you're importing NumPy, most times you'll be seeing it something like import NumPy as np. This is just like a short name that you are going to be using in your code. Instead of every time you type NumPy, you can just use np, right? So this is just to make your code easier. So if you're importing pandas, you say import pandas. Instead of just pandas, you just say as pd. Right, so anytime you want to say pandas, you use PD instead of NP. So if I come here and I use that particular dir for NumPy, so me to write NumPy, I'll just write NP. So this NP is representing NumPy. It's like an alias. So I'll just come here and print. I'll come here and print dir. Right. So let me run it first. Run. So he's giving me exactly the same thing. So this NP is basically a way to shorten this NumPy name. So because if you are using NumPy, you'll be using this NP a lot. So yeah, that is just it for that. Take note of all these things that I just said, because you would need it as we move on. So now we are introducing NumPy. Right. So by the end of this class, you should be able to understand the fundamentals of NumPy and its advantage over standard Python lists. Create, manipulate, and perform basic operations on NumPy arrays. Apply NumPy for various numerics. So these are just the things you need to know after this class. This is the outline. You can go through them. We'll introduce NumPy. Then we'll talk about NumPy arrays. Talk about basic operations in NumPy, array manipulation, aggregation functions, and so many other things, right? So now, what is NumPy? I've been talking about NumPy, pandas, NumPy. What exactly is NumPy? So NumPy is a short name for numerical Python. As you can see here, numerical Python. The name has given him the functionality or what it does away already. So this library does everything that you have to do with numbers, right? Everything that has to do with calculation, multiplication, or mathematical operation, even the arithmetic operation that we talked about, everything. NumPy does all those things and even do it efficiently, better than normal Python will do it. So NumPy is the standard library for every numerical operation or numerical computing in data science, right? So even if you want to just learn data analysis, just normal data analysis, you have to know NumPy. If you want to learn data science and you want to go to machine learning, you have to know NumPy. If you want to advance and go for machine learning to even deep learning and AI, you have to know NumPy. NumPy is like the foundation of data science. I will just put it that way. So everything that has to do with data science is on top NumPy, right? So NumPy is like the grandfather of data science. So this library is a must know. If you don't know this library, I don't know what else it is you want to know in data science. This is like that is why I'm introducing it first. So if you just read through this thing, I will send this material, I'll drop this material on the Google Classroom so you go through it, right? So now, NumPy is short for numerical Python, is a fundamental library in Python used for numerical computing it provides support for large multi-dimensional arrays and matrices. Now we are going to be introducing new data types. Remember, we talked about some data types initially: string, integer, list, tuple, this one, that one. We're talking about the simple things. This one is simple. Don't just prepare for, or don't be scared. So we're going to introduce a new data type that is specific to NumPy. This is what NumPy uses to carry out all its operation. Everything that NumPy will be doing, it is this on top of this data type. So this data type is called arrays. Array, ARRAYS, arrays. So it's usually called NumPy arrays or NumPy array. I would explain that. We'll talk about it. Don't worry, that is why we are here today. So it uses NumPy array along with the collection of mathematical functions to operate on these arrays efficiently. So now, as you can see here, NumPy is at the core of almost every scientific and computational Python ecosystem. Like this is something you just need to know. NumPy is the core of everything that has to do with scientific, not just in data science, even in people that do all this rocket science, right? All these guys, engineers that work in NASA, all these big companies, they use NumPy, right? If they're using Python, it is NumPy they will use because NumPy is very, very efficient. I'll talk about that later. So NumPy is at the core of almost every scientific and computational Python ecosystem, serving as a foundation for libraries such as Pandas, SciPy, Matplotlib, and more. I don't know how else to emphasize this, but just please know that NumPy is very important. Right. So now let's move on. So at its heart, NumPy offers an ND array, that is n-dimensional array. So the array is the basic object used in NumPy. So this array can be one-dimensional, it can be two-dimensional, it can be three-dimensional, it can be four-dimensional, it can have as many dimensions as possible. But don't worry, we'll talk about that later. But just have this at the back of your mind, right? So this array is actually a very fast and flexible container for large data sets in Python. So when you guys mature, just read through. So I have just summarized what NumPy is, right? So now let's go straight to NumPy array. Now this is a data type, NumPy array in Python. So in NumPy, creating array is a fundamental operation, essential for numerical computations and data manipulation tasks. So see, just know that we're already entering data analysis. We have now moved on from Python, the fundamentals of Python. Now we are entering data analysis. So we're now entering the main thing that we came for in this program. So pay good attention. If you miss anything now, although the recording will be there for you to go over it, but try to pay attention so you pick everything that I am saying, all those things that I emphasize. Just know that whenever I'm explaining something, I keep saying something over and over again. Know that that thing is important, very important. Yeah, that's by the way. So now this is what we call NumPy array. It is a data type in NumPy. It's a data type that NumPy uses to perform all its operation. So now let's just quickly illustrate it in code. So yeah, this one is how come you say NumPy, right? So creating NumPy arrays. Perfect. So remember when we are creating lists, how do we create lists? We say my list. The same way, I like to repeat things a lot so you understand it. My list, you create your list, right? So let's just say 3 numbers. This is Python list. If we come, remember the function I introduced, the type function. You need to tell you the type of that particular object. If you print, make sure you always add print. Right. So you see, it said class list. Now, let me just take your mind back a little to when I was talking about objects. Remember, I was talking about objects, and I was saying every object belongs to a particular class. So this one, two, three, four, belong to the list class. So now the class here is list. So this object belongs to this class list. So I'm debating a little bit here, but I just want to show you something. So if I come and say type string, remember the string variable we created the other time. Okay, I didn't close it. So this string variable we created the other time is in the class string. So if you want to know the class an object is in, you use this function, type function. So be noting all these functions I'm talking about. I've talked about dir, I've talked about type function now. So be noting those important functions. So now this is just by the way. This is how to create a list in Python. A list can have multiple data types inside it. Can have multiple. You can have integer, string. Can have float. This is a list. Now, a list now is it is not very efficient for performing numerical operation or mathematical operation. That was why people that created NumPy created NumPy. So they wanted to create something that will be very, very efficient when performing mathematical operation because in machine learning we make use of plenty numbers. Like we perform large numerical operations on vast numbers of on plenty numbers, right? You get what I'm trying to say. So a list now, if a list is to perform that operation on maybe a very long list of number, is going to not be very efficient. It's going to take a long time to perform. I won't start showing you all these things now. I will drop links of YouTube video that will give you this explanation in depth. So to go in depth to show you how list differs from array, I'll just give you the surface understanding just because of time. So an array now, to create an array, all we are going to do is come here and we are going to say np. Remember, we've imported numpy as np. Remember, dot array. Now, you would understand why I talked about methods and attributes just before we started numpy now. What is this array now? This array is what? Someone should tell me in the group chat. What is this array? What does it mean? This dot array. I just want to respond. Tell me in the group chat. Exactly. Method, attribute, function for np, attribute, method. Yeah, you're all correct. Whether you say method, whether you say attributes, whether you say function for numpy, you are what? You are correct. This is a function or method specific to numpy. So you can use array to create numpy arrays. So if I come here, I would use bracket. So anytime you have a function, just know that a bracket has to follow. Inside that bracket, so this now I'm just going to be asking questions so to know exactly how you're following. So now I'll come here and say my list. Remember when I talked about function yesterday? This thing that is inside the bracket, what is the name? What do we call this regarding the function that oh, this is just I'm just so happy. Like exactly, this is an argument. Someone said parameter. Parameter is actually when you are defining the function. Like when you are defining the function and you put some placeholders there, those are parameters. But when you are calling the function and you put the actual number or the value that you want to manipulate, that is now what we call argument. And that, just understand that. So that person that said argument, one bottle for you of Coke. So this is an argument. So the array function will take an argument, a list argument. So this list is going to now what will this particular code do? This np.array with list, what will it do? Last question before I move on. What will it do? Can anyone guess? Can anyone guess what will this code do? Once they make it a matrix, it's going to rearrange the list. Okay, to convert the list to array. Exactly. Create an array from the existing list. Once they convert it to array, perfect. Yeah, it will transform this list to an array. And there's something you need to know about array. Numpy array. Numpy arrays can only allow one data type. Only one data type. So unlike list that we can have multiple data types, in array we can only have one data type. So if you convert this list now that has multiple data types to an array, what NumPy will do is that NumPy will convert all those items in the list to string. It just convert everything to string. Like it doesn't stress itself. So this is actually what makes NumPy efficient, but I will not go into details how it happens because all these things happens in memory. There's what we call contiguous memory and everything. So I'll drop a YouTube video that will explain all these things in there. Because just understand that NumPy array can only take in one data type. So if I print this, I come here and say array. I'll print array, come here and print array. You see now, I've gotten a NumPy array. If I come and print the type using type function, that is to know the data type of that object, right? And can you see what it is showing me now? Class. The class of this data type, this array list, is what? NumPy nd array. It is no longer a list. Remember, let me print this one. Print my list. Type. Hope I'm not confusing you. If you've been following from the first class, this thing should not confuse you. If you've been following, this shouldn't confuse you. So basically what I'm just trying to say and print here is just to show you exactly. Let me make this thing better to view. All right. So now this list this first list, I printed out the data type and this is the data type. It's under the class of list. So I converted it now to an array, NumPy array, and I check the data type. So the data type now is what? Numpy nd array. So just know that. So this is how you create a NumPy array. You can also create it manually by coming here and say np.array, and then you create your numbers. So you can easily create, so it will create an array for you. Now we have different dimensions of array in NumPy. We have one-dimensional array, we have two-dimensional array, we have three-dimensional arrays. So practically, you don't usually go beyond 3 dimension because in real life we are actually in a 3-dimensional world. So it is impossible to conceive beyond a third dimension. So most of the time you end up at 3 dimensions, right, of arrays. So if you're introducing a 4th dimension, it will now become more complex. But just understand that we can have multi-dimensional arrays. So if I think it should be somewhere here. Let's just go on first. So we have multi-dimensional arrays. So now to create a 1-dimensional array, one-dimensional array. So a 1-dimensional array is basically a normal list. like a normal array, like that just has a sequence of values. So it's something like this. I'll just bring this one here and copy and say um, array 1D and then paste it. So this is a one-dimensional array. I can come here and say print one-dimensional array. Array. Hope everybody is still following at this point. Let me know in the group chat. Hope you are still following. Okay, there's a mistake here. Please, if you are still following, let me know. Let me know. Okay. Okay. All right. So I'm going to just, you can ask your questions later. Just note your questions, but I would try to slow down a little bit. So now I'm trying to create arrays, right? We are trying to create arrays. So now, as I said, we are entering the main data science and the main data analytics. So take your time to understand it. If you are not understanding it now, once the recording has dropped, go through the recording. That's why we are giving you the recording. So you would take your time and digest everything. So because of time, I would have to just proceed with what we are doing for today. So basically, all these things I'm doing here, don't let it confuse. This is just string formatting. This is string formatting that we taught, that we discussed last week. Right? This is string formatting. So don't let it confuse you. So then this is one-dimensional array. To create a two-dimensional array, this is how we basically create a two-dimensional array. There's something here, problem here. Okay, yeah, I didn't close this thing. All right. So this is how you create a two-dimensional array 2D, and then you say np.array. You still use the same np.array, but this is basically how you arrange your array. Your two-dimensional array would have two brackets initially, 1, 2. Then to have numbers, the first column, then brackets, right? And then can enter and then create your order values and then terminate it with the two brackets. So this is how a two-dimensional array will look like. So basically a two-dimensional array has what we call rows and columns. So the vertical position, the horizontal position or the horizontal values are the rows. 2, 3, 4. 2, 3, 4 are the rows. 4, 5, 6 are the rows. So this is the first row. This is the second row. And it has what we call columns. This is the first column. This is the second column. This is the third column. So this is basically what a two-dimensional array is. So you'll be working with a two-dimensional array as we move on and as we do other data analysis stuff, right? And moving forward. So understand one-dimensional array. You use np.array and then you create your one-dimensional array. So one thing to note is that one-dimensional array usually have just one bracket. Two-dimensional array will have two brackets. Then three-dimensional arrays would have 3 brackets. So if you come here and say array 3D, so we'll say np.array, it will have 3 brackets. So you have your first set of row, then your second rows, close the first brackets, then you come down again and create your second set of it's just like having two-dimensional it's actually a tongue twisting sentence. So you would have two-dimensional arrays in three-dimensional arrays. So you have your first two-dimensional arrays here. You now come down and have your second two-dimensional arrays. So you terminate it with three brackets. So you see, anytime you see three brackets at the start and three brackets at the end, just know as a three-dimensional array. So I'm just going to stop here now for just for now before I continue to take questions, because I know it's getting a little complex. I won't lie. We're actually moving forward, and we are meeting some complex concepts. So I'll just give a few minutes. Let's say 5 minutes. Five minutes for questions. So if you have any question, please let me see your hand and I will unmute you to speak. All right, Solomon, please, you can go on to speak. I've unmuted you. So Babatunde, you are next. I'll take three questions. So Solomon, Babatunde, and another person. So Solomon, please, I unmuted you. You raised your hand. All right, Babatunde, please go on to speak. I've unmuted you. Eniola and some other persons, I saw your message on the group chat saying it is complex. So this is your chance or your opportunity to ask questions so I can clarify you. So Babatunde, please. Yeah, I can hear you.
Okay, the question I want to ask is that when you are talking about the one-dimensional array, I noticed that it only has one row. Then the second dimensional array has two rows. How come the three-dimensional now has 4 rows? I don't understand.
It doesn't actually have 4 rows. It's a little bit complex to visualize, but let me just show you exactly what is happening there. So, okay, there's even supposed to be a bracket here. So now a one-dimensional array, I have 1 row, right? Sorry, it actually has more than 1 row. It has 4 rows. 1, 2, 3, 4. We count this as rows. So it's supposed to be like this. This is how it's supposed to be visually. So this is how it's supposed to be. One-dimensional array, 1 row and 0 column. Your two-dimensional array have 2 rows. This is the first row, this is the second row, and what? 1, 2, 3. It has 3 columns. Your three-dimensional array now is a little bit different. Now, this is your first row. We have I told you that your three-dimensional array, the way you can understand it, that it has 2 or more two-dimensional arrays. So now this is, as based on what we talked before, this is a two-dimensional array. That one, as you are done with that. So now you have to come and create another two-dimensional array in a sense. So this array here and this array, they are not together. They are different. So you cannot count it as together. You cannot count it together like 1 row, 2 row, 3 row, 4 row. No, that is not how you count it. You count it as 1 row, 2 row for the first array, and then you come here 1 row, 2 row for the second array. So let's assume you have a third array. You can come here and create it, and you just say 3, 5, 6, right? You say 6, 8, 7. So now you have one dimension, right? So this is basically, you can have multiple of this. So this is the first set of array, your second set of array, and then the third set of arrays. So this one, and this one, they are 3 different things. So this is basically how you would have your 3 dimensions. This is basically you have your 3-dimensional arrays. They are not together. This is a bit. We are taking a step further a bit in terms of complexity, right? I would understand completely if you don't understand the concept of 3 dimensions immediately. So that is why I'm going to send you some videos to watch. If we have enough time, I will break it down, but we don't have time. We have a lot. So I'm just going to try to give you the overall understanding so you would have an idea. So once I drop the video materials on the classroom, please go through it. It's not there for fancy. Go through it. And at the end of this class, I'm going to show you something, right, that you can also use. So basically, don't count it together. Don't count it together. So yeah, I wish I could have said more on that, but because of time, I'll just have to take the next question.
Yes,
But
sir.
I
Thank you,
hope
sir.
that gives you an idea of what 3D arrays are now.
Yes, sir. Yes, sir.
All right, so Solomon, you were speaking. Please go on to speak. I've unmuted you.
All right, thank you. Can you hear me?
Yeah, I can hear you.
Yeah, good evening. Thank you very much. The lecture is actually going well. One of my questions I wanted to ask is what he just asked just now. One more so. I that one dimensional array actually I don't understand it well. But and
You did not work.
what I want to also know is can we can you print the array list so that I can see what is inside? I don't know if I'm faster than myself.
I can hear you. What
Do
was the
you
last
understand me?
question? What was the last question?
I said the first
Your
question
line is
is
breaking.
oh shit. Can you hear me?
Yeah, I can hear you, but it's breaking
Hello?
like as you speak. You know what?
Oh,
Just probably at the end of the class, if your network gets better, just because of time, please. Your line is breaking, and I can't get a grasp of your question. So yeah, I'll take two more questions. Philip, please, you can speak. Philip Obot, you can speak. I just unmuted you now. Please, we don't have time. We don't have time. Moses
Hello, can you hear me?
Nuibu, please go on to speak. Moses, please go on to speak. I just unmuted you now.
Good evening, sir.
Yeah, good evening, Moses.
Yes, my first question is supposed to be the one Solomon asked, so I'm okay with that. Now, the second one is I wasn't in the first and second class, but this F that you put here is what I don't understand. Where you say print one-dimensional array, but before you put that one dimension, there is an F in front. So I do not know the symbol for that F. What does it mean? Go up
Are
here
you a
where
new
you say
student?
print F. Yeah, print
Are you a new
F. Look at
student?
that.
Are you a new student, Moses?
Yes, sir. Yes, sir. Yes, sir.
Okay, okay, that's understandable. Have you gone through the the second okay,
It's the
yeah,
first
it's understandable.
time.
Yeah, we've actually not discussed that. So please bear with us. The video for that particular week that would explain all these things, F string formatting, would drop today, this night, so you can go through it. So I've
Okay,
explained all this, so you'll see it there. Thank you very
thank you
much.
very much.
All right. Um, um Philip Obot, I just unmuted you. Please speak. If you are not available, Ademoye Aruna, please, you can go on to ask your question. This is going to be the last question before we continue. Ademoye, please, you can ask your question. You are muted. Okay, please, there's no time. If you have any question, I'm going to give you like 5 seconds. If there's another question, we'll proceed.
Can you hear me now? Can you hear me now?
Yeah,
Hello.
I can hear you, but I think your voice is quite low. Can you kind of increase your voice so I will hear you
Can you
better?
hear me now? Is it better now?
Yeah, it's better
Is it
now. It's
better
better.
now?
Yeah.
All right. Good evening. Thank you for the session. I'm also one of the new students.
Okay.
My question goes though. Not even a question, it's a suggestion. Like the part of that matrix or the array rather. Is it possible if we could get something like a board, a writing board, so if you could just sketch something, maybe like a matrix so that we can see and understand it easy?
All right. Thank you for the suggestion. So the thing is, we are trying to. We don't have enough time, right? So there are a lot of things to talk about, and going in depth to how arrays are is a different thing entirely. So that is mathematics on its own. So we would have to take, we would actually have to spend a lot of time doing that. So the essence of your Google Classroom is that I will post some additional materials after the class that will help you understand better some of the things we've discussed in class already, right? So I honestly wish we have enough time. So I'll do all these things. There are a lot of things to do to help to drive home points, right? But we have limited time, so that's just it for that. I'll be dropping some useful materials that you would have to reference to have you to get just give you a better understanding, right? So please just pay attention to the information that will be sent to the classroom. I think that should answer your question. Are you good with that? Are you good with that? All right. Okay, so I think we'll have to continue and take questions after, because we still have quite a lot of things to discuss. All right. So, but I've taken note of what you said, Philip. I've taken note of what you said. Hopefully, I would incorporate that into subsequent videos or subsequent classes, right? So you can have an understanding of some of these concepts. All right. So let's just continue from where we stopped. So now, okay, what is going to happen is that I'm going to either make a pre-recorded video explaining this array sets and drop it on the Google Classroom, or I'll send you a YouTube video. So just the thing is, just pay attention to what is going to be dropped in the Google Classroom. All right, so now we're talking about how to create arrays. We talked about 1D arrays, 2D arrays, and then 3D arrays. So these are actually called matrices too. Like if you did mathematics and if you remember your mathematics, you understand that these are actually matrices. So they are fundamental. It's a fundamental concept in Numpy. So let me just make this array easy to visualize for you. So this is a 3D array. So now let's start from the first array. This is the 1D array. It's a single column. It has 4 rows. This is a second dimensional array. It has 2 rows and 3 columns, right? As you can see it arranged here. Now this is a 3D array. So you can see how it is organized. It's organized as 2D array, right? So it has what? One 2D array, another 2D array, and another 2D array. Right, so it has multiple 2D arrays stacked as one array. That is basically what the 3-dimensional array is. It has multiple 2D arrays stacked as one, right? So you get to understand this better, but let's just move on from here. So now all these arrays, they are objects, as I've said before, and they have attributes and functions that you can use to describe them. You can also use it to perform some certain action, right? So let's just look at some of those attributes. So the basic attributes for arrays we have in Numpy are shape, D type, size, and number of dimension. Right. So what do these matrix tell you about the object? So the shape attribute returns the dimensions of the array as a tuple. The D type is just like the type that we've talked about, but it specifies the data type of the elements in the array. So it tells you the kind of data type that is in that particular array. While the size returns the total number of elements in the array, and the ending returns the number of dimensions of the array. So basically, let's illustrate that to see what all those things that we just talked about mean. So if we come here and we use the array 1, that is the 1-dimensional array, and we access the attribute of shape. So now there's a very, very important difference between attributes now and methods. You know, I said that initially. If you are getting the attribute of an object, you don't use the open and close. You don't use the bracket, open and close bracket, basically. Okay, I've not run this thing yet. Okay, let me see if that is correct. In parentheses, okay. Okay, great. So now, once you're getting the shape of or the attribute of a particular object, you don't use the bracket because it's not a function. Attributes are just characteristics of the object. It is not a function that the object can perform. So now, as I said, we have 4 attributes, or like based on what we just discussed, we have 4 attributes of arrays. So we have the shape attribute. So it tells us the shape of an array. So if you come here and get the shape of the 3 arrays we created, 1D, that is 1D, 2D, and then we have 3D. 3D, and we print the 3 of them. Print. So this is what we're going to get. So basically, this is the shape of the first dimensional array, the shape of the second dimensional array, and the shape of the third dimensional array. So what does this number mean here? Remember I was telling you about rows and column, right? I told you that the one dimensional array has 4 rows. The 2-dimensional array has 2 rows and 3 columns. So the first number here, whenever you get the shape of an array, the first number here is usually the row, while the second number is the column. So you see here that we have 4 and we don't have anything else here. Why? Like, who can tell me why this is like this for the first dimensional array? We have 4 here and we don't have any other number here, but in the other ones we have other numbers. Like, let me get responses in the group, please. Who can tell me why we have just one number here? All right, you said there is no column. It has just one column, 0 column, no column. Exactly. So that is basically what this means. So the first number is the row. It has 4 rows with 0 column. While the second array, 2D, has 2 rows and 3 columns. As you can see here, it has, let me print them out here. You can always go back to this video and take your time, pause, like just take your time to digest it. Right. So even if you don't understand it completely right now, it's fine. It's actually very fine. Right. So if you print this is what we have here. All right. So basically that one is just there. So basically the second dimension has first, this thing is the row, second is the column. Why the third dimension? As you can see, this is the row. Now, this is the first dimension. So the reason why it is called one dimension is because it's just rows we have here. Is a one-dimensional stuff. The second dimension, the reason why it is called 2 dimensions is because we have 2 different dimensions. We have the dimension of the row and the dimension of the column. So it is 2-dimensional. Why for the 3-dimensional? We have the reason why we call it 3-dimensional is because we have 3 dimensions, 1, 2, 3. So this 3 now is the row. This 2 is the column of each dimension. Why this third dimension is the number of channels. I don't know exactly how to illustrate that verbally, but it basically, this first one is the first channel. The second one is one channel, and the third one is the third channel. So we have, in each of them, we have 2 all right. So the thing is, like, this 3-dimensional array would have to dedicate a separate video for that. I'll do a pre-recorded video explaining and breaking down how it works and how to understand it, right? Because if I start breaking it down now, we don't really have time again, and we also have other things to do. So just understand this shape attribute. So if we look at the second attribute, which is size, size. So this is basically going to tell us the total number of elements in that array. So the first array, which is your array 1, your one-dimensional array, it has 4 elements. Second array, it has 6. Third array, it has 18. So if we check, this first array has 4 elements. That is the size. This one has 6. That is the size. This one has 18. That is the size, right? So if we come here and we use another attribute, which is let's check. We have shape, d type, and size. So if we come and check the d type, and d type. So as you can see, all of them are integers. Integer, int 32, int 32, int 32. So this is actually the data type that you created this array with. So it is an integer. But if you created it with float, the data type will be float. So this 32 that is here, don't get confused or don't allow it to confuse you. It's a special kind of integer. They have different kinds of integer. We have int 32, we have int 64 rather. So this is just a type of integer. So don't think so much about that, but just know that this is an integer. So I told you that Numpy is used for numerical computation. So it is very specific with a lot of things. So you will see that specificity as we move on, right? So we have the last one, n dimension, ndim, and then we have ndim. So what is ndim? This is an attribute. It tells you the number of dimension of each array. So if I print it, it will give me 1, 2, and 3. So as you can see, this is 1 dimension, 2 dimension, 3 dimension. So the first array is 1 dimension. So basically, these are just attributes of array. These have to create an array in Numpy using Numpy, right? So if you don't get it now, just don't worry. You can go through the video again with other resources that I'm going to send on the Google Classroom, and hopefully I'm going to make a pre-recorded video explaining some of these concepts as I think Philip suggested. I will take note of that. So I need you all to understand this Numpy array concept very well, because it is foundational, and it is the building block of every other thing we are going to be doing in Python. Right, so please don't give up. Like, this is we are just starting. You want to become a data scientist, you need to put in your effort. You need to take your time and learn. Like, it is not a walk in the park. So, but it's going to be definitely worth it at the end. So you are going to enjoy it definitely. Like, if you follow up with everything we are going to be doing, both the lectures. I say this repeatedly because I know the effectiveness and how important it is. So just follow up with everything we are doing, right? Follow the class, follow the materials and resources. Come on the group chat, look at what your other classmates are saying. You can also discuss on the group chat some of this concept I'm teaching here. Some person can just come on the group, post a link, or try to ask questions, right? So just initiate conversations. There are different ways to learn something. So the thing about lecture is that lecture does not give you everything you need to learn that particular concept. It is like a foundation. It just gives you a start. So there are other factors that come into play to understanding or gaining in particular skills. So don't just rely on this lecture alone, right? So learn to learn. Yeah, learn to learn on your own too, right? So that is it for array and creating array. I really wish we have enough time because we have a lot to discuss. So we will talk about other things, like there are other ways to create arrays too. Like, we have other built-in functions in NumPy, like np0s, np1s, np_arrange, np_linspace. So I'll just go through these different functions. So you see that we have other ways to create arrays aside this np.array. So now we can create an array using np np.zeros. So I can come here and say np.zeros. This is a function, so it has a bracket and an argument. So the argument there is usually a tuple of the shape that you want to create. Remember, we checked the shape of the array we created at that time, and it gave us rows and columns. So this NP0 would someone said water break. Okay, I think we'll put that into consideration. So NP0s now, what you put here as argument is the shape that you want to create. So let's say you want to create an array that would have 0. Everything, just like this NP0 would have 0 as all the elements. So you want the shape to be 5 columns and 2 rows. What are you going to do? So I want to create a 0 array of 5 column and 2 rows. What number am I going to put and in what order? Let me see in the group chat. I need feedback. How am I going to put it here? I need 5 columns and 2 rows. So how am I going to put the numbers in this bracket? Let me see your answers or your responses in the group chat, please. Based on what I discussed here about shape, when we use the shape bit. 2, 5, 2, 5, 5, 2. Someone said 5, 2. Okay. Someone said 2, 5. Great. Exactly. So that means you all are following. That's nice. That's nice. Some people are actually following, and that's great. So what we're going to have here, I want to create a 0 array that will have 2 columns. That is 2, comma, and 5 row. 2 rows and 5 columns. So if we run this is what we're going to get. So these NP0s, this 0 here mean everything inside the array will be 0. So there's situations where we need to do this, but just keep up with me, right? So now if you count this has how many rows? 1, this is the first row. 2, this is the second row. Based on this 2 here, it has how many column? 1 column, 2 column, 3 column, 4 column, and 5 column. So you can specify the shape of the array you want to create, right? So I can come here and say, let's say I want to create 5 rows and 2 columns. So I'll just, you see that it has changed the shape now. So it has 1 row, 2 row, 3 row, 4 row, and the 5th row. But now the column is just 1 column and 2 column. Like, do we understand this? Do you understand the shape of arrays now and how it works? So this is for 2-dimensional arrays, 2-dimensional arrays. But if you want to create just 1-dimensional array with 5 column, you can remove these 2 and put 5. Just make sure you put comma. Make sure you put comma. If you put just 5, you are going to be creating. Okay, it will give you the same thing definitely. So there's actually no difference. But it's good practice to put comma there. So once you create this is going to give you 5 rows. Don't get confused by the alignment of this element. It is aligned horizontally. So you might think it's 1 column, 2 column, 3 column. No, this is actually rows. So you have to look at it in the opposite direction. That is vertically. So it's actually 1 row, 2 row, 3 row, 4 row. So whenever you create a 1-dimensional array, just not every element there is a row. So you can also create a 3-dimensional array by putting 3 values, 5, 4, 2. It's going to give you something like this. 5. Okay, now let me just quickly explain this 3D now. So this first value here now is actually the number channels you have. So if you put 5 here, you have 1, 2, 3, 4, and 5. So the second number that follows is the row of each of them. So you have 4 rows. That means 1, 2, 3, 4. And you have 2 columns, 1, 2, right? So basically this 4 and 2 indicates the number of rows and columns you have for each of the channels, right? You would have in that array, 3-dimensional array. So the same thing with this one here. So in this case, we have 1, 2, 3 channels. So you would have, for each of channel, you have 2 rows and 3 columns. So what you have as the shape of this array is going to be 5, 2, and 3, right? So remember when we printed this here, the shape, we printed the shape here. We got this. So we understand how we came about 4. We understand how we came about 2 and 3. And we understand how we come about 3, 2, 3. Right? I wanted to take my time to explain this 3D array, but I think we just have to do that now. So this first 3 here mean that we have 1, 2, 3 channels, right? This second two mean for each of the channel we have 2 rows, and then the third number, that is the 3, means we have 3 columns. So if we add additional, let's say we add another channel, put comma, and then you come here and then you copy. What will happen to this shape? Can someone tell me what will happen to this shape? What will change here? Now that we've added, can you tell me the new shape we're going to have? Now that we've added additional channel here, let me get your feedback in your group, please. What is going to happen to this shape of the 3-dimensional array? Let me see if you understand that. Please respond in the group chat. Okay. Said 4, 2, 3. Stone said 3, 3, 2, 4, 4, 2, 4, 4, 2, 3. So those that said 4, 2, 3, you are correct. You are correct. So we are adding, when we didn't change the number of rows and columns, remember. So these 2 and 3 will still remain the same. We just change the number of channels we have here. So that is why we add 4. 1, right? 2, 3, and then 4. So that will be the first number here. So if I run this again, you can see it has changed to 4, 2, 3. So that is it for arrays and right. So this is for zeros. If you want to create arrays with zeros, you just have to indicate the shape. So you need to understand shape to be able to use this. So the next one we have here is we have np.ones. So these are functions of NumPy. So we have np.1. So let's just quickly illustrate that. So instead of zeros, we want to create an array that will have ones as the element. So we want to have 3 columns, 3 rows, and 4 columns. So this is what we're going to have: 1 row, 1 column, 2 column, 3 column, 4 column, 1 row, 2 row, 3 rows. So this can be confusing. It's simple, to be honest. This is actually simple. You can attest to that, but it can be confusing initially because sometimes you may mistake this particular direction as the row. Sometimes you might mistake this particular direction as the column, right? So just take your time to understand the positioning of rows and column in arrays. It will help you a lot. Right, so this is for ones. If you use this ones method, it's going to fill everything with 1. If you use 0, so just know that whenever you use these methods or these functions, you indicate the shape of the arrays you want in this thing. If you want 1 dimension, if you want 2 dimension, if you want 3 dimension. So we can come here. Let's just try something funny. Let's try 4 dimension. I'm sorry to complicate everything, but this is how it's going to look like. So it's going to be very complex. So you don't use 4-dimensional arrays like that. Like you mostly don't use 4-dimensional arrays. There are situations where people that do a lot of advanced stuff use it. So the next function here is np.array. Now, let me quickly remember when I talked about for loop, I introduced range function to us. What does this range function do? Someone should give me feedback or an answer in the group. What does this range function, if you remember from the class we had, what does it do? What does the range function do? We'll soon be stopping now to allow questions. So, but for now, I need us to just give me an answer to this. What does the range function do? Waiting for your responses. No one is saying anything. Have we forgotten? Or what? Have we forgotten? Yeah, a sequence of values, exactly. Used to generate sequence of numbers. I actually want us to interact, so I'll be sure that we are on the same page here. So you might notice that I'm taking my time to ask this question. So it actually generates a sequence of values depending on the range of that you specify, right? So you ask your question, like once we'll also be done with this particular session. So we'll continue with NumPy next week. It's not possible for us to finish everything in one class. So this range function is Python function, right? It generates a sequence of numbers. So let's say we put 10. To generate 0 to 9. 0 to 9, remember, right? So we'll have to convert it to a list to see what it is generating. 0 to 9. So now this is Python range. So NumPy has the same thing, np.array. a range, np what dot a range. So this basically grammar let me because what exactly is happening. All right. No, I would have to deactivate that. So numpy has what we call np.arange. What this does is that it actually generates a range of number. Okay, it generates a range of number and convert it into an array. You generate a range of number and convert it. So if you say np.arange 1 and 3, you generate the number from 1 to 2. The same thing with range value. So if we say 1 to 10, right, it will generate this. So this is basically another function we can use to generate numbers in NumPy, using NumPy. And if I can remember, I think it has another argument shape. I don't know, I think I would have to look that up, right? So this is another function in NumPy. So we also have linspace. So linspace basically generates a range of number from, so we have 3 arguments in this linspace method. We have the first argument, which is where it will start. Then the second argument, which is where it will stop. Then the third argument is how many numbers you want to generate between 1 and 8. So let's say between 1 and 8, now I want to generate only 2 numbers, I'll put 2. So if I run it now, I'll just see 1 and 8. If I say I want to generate 3 numbers between 1 and 8, I'll say 3. It will say 1.0, 4.5, and 8. So it generates 3 numbers. So it basically generates all these numbers, they have equal intervals. So at equal distance with each other. So all these functions you are seeing here, they have very specific use cases as we are going to be moving on. So that's why I'm introducing it now so you understand. So if you put 10 here, to generate 10 numbers between 1 and 8. So this one is like the limit, right? So if I change this 8 to 20, it's going to give me 10 numbers between 1 and 20. Do we understand that? Right, so as you can see, this is 1 here, this starting, and this is 20. So if you count the number of elements here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so it's 10 numbers that is there. So just understand that. So those are just important functions that we can use to generate arrays in NumPy. So you see examples here. We have examples here, and something you can actually play around with. So everything is just here, and so this is it for NumPy. We've introduced NumPy to you, right? And we've not exhausted everything yet, right? We are going to continue there where we stop next week. We'll continue with the operations we can do in NumPy. So NumPy has several operations, mathematical operations that we're going to talk about. So we won't be able to talk about it in this class because of time. So we'll be stopping here for today. Yeah, but there's something I just want to quickly talk about before we stop. It is called slicing. Like, I'll just quickly go through that. Remember in our list, when we created a list, let's use my list. We have my list, right? If you want to access, all right, I'm going to, this is for the class now. If I want to access Python now, only Python, how do I do it? I need the syntax on the group chat. What syntax will I use? I need the exact syntax. What will I use to access Python? This Python, I want to print this, access this Python and print it out from this list. How do I do it? I need someone to give me the answer. We've discussed this already. Exactly. I love that. Oyeyemi Akinwole. Let me see other responses. All right, my list with bracket. Yeah, exactly. My list three. No, Aisha, your bracket, it should not be normal. It should be a square bracket. It should be a square bracket. Remember the indexing we talked about, right? We talked about indexing. Exactly, Yusuf. We talked about indexing of list. So if you want to get any element in the list, you use this particular syntax, my list with square brackets with the index number. Let's say Python now is here. So we can just use 1, 0, 1, 2, 3, 3, right? It will give you Python. So this is a way to access the elements in a list. So we can do the same thing with NumPy, right? We can do the same thing with NumPy. So we can come here and say, remember I said that you can actually access multiple numbers in a list. So you can come here and say from 3, let's say from 0 to 2, it will print out 1 and 2. That is the 0 index and the first index, right? It will not print out the second index. So this exact concept we talked about in when we were talking about list is the same thing now for arrays. We can also access arrays. Let's bring out this first array. So we have your array 1D. So your array 1D is 1, 2, 3, 1, 2, 4, 5, right? So now this one-dimensional array is like list. Like you don't need to do any other things. Like let's say if you want to access 4 here, you just have to do 2, right? You just have to do 2, and it will give you 4. It's like list. You don't need any other additional knowledge. But if you are working with a higher dimensional array, like 2-dimensional array, now we have rows and columns. So in anything higher, in 2-dimensional array, we have rows and columns. So if you want to get a specific value in a 2-dimensional array, we're going to pay attention to the position of that number in the row and also the position of the number in the column. So how do we do that? We'll come here and then we'll put our square bracket. So the first number we're going to put is the row. So let's say we want to get 5 now. We want to access 5. Where is 5? Is 5 in the first row or in the second row? Let me get responses. Is 5 in the first row or the second row? Second row, exactly. What of colon? Which colon is it in? Yeah, which colon? What of colon? Is in the second colon. Yes, what of colon? Second colon, exactly. So if we want to access this 5, if we want to index this 5, what we're going to do here is going to come here and put 2. This first number will stand for the row. And the second number here will stand for the colon, 2, 2. So, sorry. What we are supposed to have here is 1, 1. Let me explain. So we have our array 2D. So now your array is also next. Listen very carefully. The rows in your array, they are indexed, and the columns too, they are indexed. So this first column here, 2 and 4, it is at index 0 for the column. This 3 and 5 is at index 1. This 4 and 6 is at index 2. Why the row? Also, they are indexed 2. So the first row is 0. Second row is 1, right? So if you want to access 5 now, we're going to say, oh, the second row here is not 2 you are going to put there, right? 2 is meaning third row because it's the index number we are accessing. Exactly. Indexing starts from 0. So you put 1 here. This 1 means second column. The same way in your list here. 0 means the first number, right? So the same concept is translated to NumPy. So if you want to get 5, we'll do 1 and 1 and we'll get 5. So the first number here is always the row and the second number here is what? Always the column. So if we want to get the first row, only the first row, we're not going to include any column here, any column number. We'll just put 1, right? We'll put 1. And this 1 is going to bring out the first, the first row is supposed to be 0. 0, right? So it's going to bring out the first row, which is 2, 3, 4. As you can see here, 2, 3, 4. If we put just 1 here, it's going to bring out what? The second row. So if we want a particular number, we're going to have to combine rows and column indexing. So if we want 3 now, we're going to have to combine, okay, what are we going to have in this particular bracket? If we want to get this 3, if we want to get this 3 value, what number are we going to have in this bracket? Like what is going to be the indexing here? Someone said 1 and 1. No? Okay, well, that was the first one. 0, exactly. 0 and 1. It's going to be 0 because 3 is in the first row and 3 is in the what? First column, which is at index 1. The second column is index 1. The first row is index 2. You just have to take your time to digest all this I'm saying. So you'll be 0 and 1. So you get 3. Is that clear? So this is basically how you index arrays in Python. You have to combine the position of that value in the column and the position of that value in the row. So next class, before we continue with this thing, okay, for the assignment, I'm going to give you some questions that will just help you practice more on this indexing. But there'll be a video I'll put in the Google Classroom to help you understand this concept better. So is there any question? We're going to wrap it up here. We're going to wrap it up here because of time. We're already past 5, I'll be 7. So is there any question? I'm going to give time for question. All right, I'm going to be taking 5 questions. Awopeju, Faith, David, Kim, David. All right, so Awopeju, Oluwaseun, I'll be unmuting you now. You can ask a question.
Very much, sir. When we're converting the list to an array, the second index element of the list was a string. So by the time we converted it to array, all the elements of the new array now are string. Is it because one of the elements of the list was a string? That's my question.
You've answered the question, sir.
So assuming all the elements of the list are numbers, they will also be numbers.
Let me explain. I told you initially that NumPy works with just a single data type in its array, in its array. So it doesn't have multiple data. You cannot have 2 different data types in a NumPy array. So it's just one. So when you're converting a list to an array and you have multiple data types in that array, NumPy will never know what to do with it. It will not know whether to convert it to it would not know whether to convert it to a float because you have a string there. And it does not make sense converting Python, which is a string, to a float or an integer. So it will just convert everything to a string, right? It will just convert everything. So it makes sure that every item in that list is one data type. It is very essential that it is that way so that the computation will be very effective. So that is it. Once there are multiple data types in a list and you're converting it to a NumPy array, everything will become a string automatically. I hope that answers your question.
Thank you, sir. Yes, sir.
All right. Faith, please, you can go on to speak. I just unmuted you. You are muted. Faith Ogechuku. Please, you can proceed to ask your question. Hello, Faith. All right, Kim David, I'm muting you now. You can go on.
Hello, can you hear me?
Yeah, go on. I can hear you.
Okay. Good evening. Thank you so much for this wonderful session. I'm a new student. I just got admitted recently. But the issue I'm having now is that I've not been able to download the Anaconda software. I've followed.
Okay.
Yes, I went to the Google Classroom. I've been able to finish the first assignment. Then I've been able to go through other materials. And then I tried downloading the Anaconda through the link that was sent on the classroom. I followed all the procedures, but then after clicking on the download link, there's something that is coming up on my screen that I did not understand. And this has made me, I've not been able to understand the class since yesterday. I attended the class yesterday, but I didn't understand what is going on, even till
Oh,
today.
I'm so sorry
Yes,
about that. Are you using a Mac or a Windows?
I'm using Windows.
All right. The thing is, I would have to see exactly what the issue is. So please just send me a DM immediately after this class so I can walk you through it and hopefully resolve the issue.
All right, no problem. Thank you.
Thank you. All right, Kim David, please go on to ask a question. You are unmuted. Kim David, you can proceed to ask your question. Okay. So, are you there? Okay, Babajide, please go on to ask your question. You are muted.
Thank you for this answer. My question is, uh, uh, during the class, we have been using the kind of array that we are using. It always has two rows, two rows. Is it possible for us to have square matrix whereby the number of rows and columns will be equal? And then if that is possible, is it also possible that we could have, if we want like for example, if we want number one to be
Your line is
only
breaking. I can't get what you're saying. Can you repeat yourself, please? The first part.
okay, can you hear me now?
Yeah,
Can
repeat the
you
first
hear me
part.
now?
Yeah, I can hear
Okay,
you.
the first one. Okay, now the first one I asked is that, is it for us to have a square matrix, a square array, whereby the number of the columns and the rows will be equal, like 3 by 3, 2 by. So
Yeah.
that's the first one. That's the
Okay.
first one. So
Right.
the second one is that you did something during the class when you were using .0, np.0, whereby all the entry in that array is 0. Is it
Yes.
possible that we can also have a situation whereby we only have one only in the diagonal and the other numbers, the other entry will be 0? Is it possible for us to do that with NumPy?
Yeah. Yeah, there are actually functions that you can explore. I think np.i can do that. There are a lot of things you can do with NumPy arrays, right? I won't really start going through them one by one, but these are the main ones that you just need to know. Like the one you mentioned, I know that. I know what you're trying to say. So that's it for that. You can explore on your own. There are possibilities, right? There are possibilities that we can explore in this class. For your first question, it is possible to create a matrix that is even, right? You said each row and column is even an even number. Yeah. So if you come here and say np.0, just a quick one, and you say 3 by 3. This is both rows and column is the same number, so it's very possible. I think that should answer your question. I hope that answers your question.
Yes, sir. Yes, sir. Thank you, sir.
All right, so Kim David, please proceed to speak. You were raising your hand.
Can you hear me, sir?
Yeah, I can hear you, sir.
Yeah, thank you for the lecture today.
All right, you're
I
welcome.
wanted to ask, yes, before we started using NumPy, we had to import the library into our workspace.
Exactly.
So the question I have is it going to impede every other thing that we have been doing on the workspace? Then secondly,
What do you mean by that? Sorry. Impede. What do you mean by impede?
is it going to stop every other action we have been carrying out on the worksheet?
First of all, let me just answer that question. I don't know exactly what you mean by that, but it won't affect anything you are doing. You are doing a separate action. So you don't need to worry about it affecting anything or impede any process that is currently going on in your worksheet. So yeah.
Okay, thank you, sir. Secondly, yes, can we also please get, if possible, this sheet you are using, this file that you are using as your rough sheet to give us examples, if it's possible, sir? It's going to help us. Thank you.
Okay. This is just actually a rough sheet for the class, and I don't know how that is, but I will drop it. Since it's you are the one learning, right? So whatever it is that will help you learn better, that's fine by me. So I'm going to also drop the rough sheet on the together with the material this night, so you can also go through the examples I've given. Okay,
Thank you, sir.
that answer your question. Please, any other question? Any other question? Okay, great. I think in the absence of any other question, we're going to be rounding up with today's class. Before we round off, I just want to quickly show us something. I want to quickly show us something. So I'm going to share my screen. I'm going to use this one and share a particular screen. Okay. So if you see my screen, you see a book, a PDF file. I sent this Python book to the Google Classroom in the first week. So that book was the PDF or the book is not there to beautify your computer or just to occupy space. It is there for you to read. I don't know how many of us have opened this book since I sent it. So now that we've started NumPy, this is going to be your reference. This is like, in every class, they have a textbook that they use for that particular course. So for this course we are doing, this program, this is your handbook. Everybody must have it. I have sent it to the Google Classroom, so everybody should have it. You should be referencing it, going to it after each class, even before the class, just seeing examples, reading it, and basically the way you read the course textbook for any course you are taking is the same way you should read this book. So for today's class now that we did, which is on NumPy, if you go to the course outline here, you'll see, let me zoom in. If you go to the course outline, you see we have Introduction to NumPy. So if you click on it, it will take you to NumPy Chapter 2. You see the introduction, introduces NumPy, explains so many things, right? Even give you in-depth explanation, right? Under steps in Python. You tell you exactly why NumPy is more efficient, and so many things, right? Python integer, a lot of information that I might not even mention in the class, even with illustrative diagrams. So this textbook, this PDF should be your reference for this particular course. So this is what we're going to be using for the rest of the course. Everything we are doing is here. All the things I've said today is here, right? So everything. So please, for this particular lecture today, go to this chapter 2 and read the ones that we've discussed. As you can see, a lot of things here, even some things I didn't even discuss. So it's very comprehensive and elaborate, right? Creating arrays from scratch. As you can see, a lot of examples. Here. So you can see lecture is one thing, right? Lecture is not going to 100% give you, it's not going to give you 100% of what you need or to become what you want to become. It's going to give you a starting ground for you to build on. So please learn to read, learn to make further research after our classes and extend yourself, right? So don't limit yourself to just what we are doing in the class. So this is just what I have to show you. So please, as you can see, the data type I even talked about, int32 is here. You can see it explains what int32 is. So this is the range of numbers. So a lot of things. So please go through this book. Please, it is on the classroom. Once you go to the classroom, go to week 1. You see the book there and one other book I sent to the classroom. So that is it for today. We're going to be stopping here. If you have any question, please drop it in the group chat, and I and my assistant would attend to it. So, okay, one person raising the hand. I would love to take one more question. All right, Matthew, you can go on. Matthew, please, you raised your hand. You are on mute now. You can go on to speak. Unmute yourself and speak. All right, great. So you can just drop your question in the class group chat. So that's going to be it for today. Thank you very much for your time. Hope to see you again next week, Saturday. And expect your assignments for this week. You'll have been doing great so far. I believe you even do better this week. So and try to submit your assignment before the deadline to see you soon and have enjoy the rest of your day. Thank you.